Cool. All right. Welcome to our bi-monthly Dagster community meeting. For those of you that haven't joined before, this is a meeting we have for our users and friends to give them updates about the Dagster project and the Elemental company. We also often have our users and customers come in and showcase their creative ways of using the Dagster framework. From the Dagster team, today we'll be sharing product updates that we're excited about. They're mainly focused on the OSS product. Sometimes we'll feature something specific to Dagster Cloud, but we want this to be a forum that is applicable to all of our users. We also use this time to give our community a live opportunity to ask the Dagster team some questions. So feel free to drop some questions in the YouTube chat as this meeting's going along, and someone from the Dagster team will answer them during the session, or we'll answer it during our Q&A portion at the end. Now let's go into what our agenda is, because we have a very packed hour going on. First of all, we're going to be going through some announcements, as mentioned, about Dagster, and then we're going to go into some community spotlights and highlight some content that people in our community have made. Then we're going to have Sandy talk about the recent additions and changes made to partitions, and Nick is going to be talking about recent improvements to the resources and configuration system. At the end, we're going to leave some time for some Q&A for you to ask questions and have the Dagster team answer live. And then we'll leave some last announcements at the end, and we'll go from there. All right, first, let's go into our announcements. Since the last Dagster Community Day, we have released 1.3, and as part of that, we are also now releasing since our last Dagster Community Day, we released 1.2, and we are soon to release Dagster 1.3. However, part of that is that we want to collect feedback for what we want to name this release and would like your input. We have a GitHub discussion up to get your suggestions and votes. I'll drop the link for it and YouTube chat and the Dagster Slack below. In addition to that, if you're interested in seeing more about Dagster, you can hop on over and sign up for our bi-weekly live demos, in which they happen every Thursday at 9 a.m. Pacific time, in which you can meet with someone from the Dagster team, and they will build out a moderately sized Dagster project live, and you can ask them questions either about the project or what you're building out synchronously. Next up, we have some community spotlights. First, wanted to highlight a talk that John Neo did at Data Talk Summit earlier this year, in which he talked about data-aware orchestration that was enabled by Dagster. Then also we had Vinny from our community talk about using Dagster, his decision process about why he chose Dagster, and how it's been since he's adopted it, recently on a podcast. Then after that, let's move on to Sandy, who is ready to talk about partitioning and the changes we recently made of 1.3 about partitions.
Hello. Window. Share screen. There we go. So I'm Sandy. I'm the lead engineer on the Dagster project. I'm going to spend a little bit of time talking about Dagster and partitions. Dagster's most recent release, 1.2, includes a bunch of big improvements to Dagster's partitioning functionality. We've actually made so many changes in the last 6 months or so that I thought it would make the most sense to basically present partitions from the ground up. As a consequence, if you're an experienced Dagster user, some of the content at the beginning of the presentation might be familiar to you, but there are enough new bits that if you stick around, you're likely to learn something new as well. Before I jump into demos, I want to talk a little bit about the what and why of partitions. Partitioning is a technique in data engineering that helps organize data and the computations that produce that data. The idea is that a data asset can correspond to a collection of partitions that are tracked and computed independently. Typically, each partition corresponds to a separate file or a slice of a table in a database. Sometimes partitions correspond to time windows, like daily or hourly. And other times they correspond to sets of entities like countries, customers, or financial instruments. Partitioning is useful for a couple main reasons. The first one is performance and cost. So it allows you to operate on subsets of your data, which means you don't waste computation rebuilding your data from the ground up every time that you need to update it. And then the second one is organization. When you scope an operation to a subset of your data, you know it's not having unwanted side effects on other parts of your data, and it's easier to understand what's going on and what went on in the past. Dagster takes partitions very seriously. As a data orchestrator, Dagster is in the business of modeling the relationship between computation and data. A data orchestrator's job is to keep data assets up to date, and to understand whether a partitioned asset is up to date, you need to know when each partition was last updated. It's both very important and very useful for Dagster to understand this at a deep level. So now I'm going to explore in some detail what it actually means for a data orchestrator to support partitions. And roughly, this is going to be divided into 4 sections, corresponding to different ways to partition an asset. We're going to start by talking about time window partitions. So for example, we might have a large table of events that are collected from a website, and it might be partitioned by hour. Each hourly partition could correspond to all the events that occurred within that particular hour window. And maybe at the end of each hour, we want to append all of those events for that hour to our table. Here's how we define it in code using Dagster's APIs. We construct an hourly partitions definition object and attach that to our asset definition. And then we write our code in a way that it takes the partition as a parameter. In this case, we're doing that by accessing context.partition key and using that to determine what file to write to. It's ultimately up to us as the user to decide how Dagster partitions correspond to the data that's persisted in our storage system. Once we've defined this asset, here's how it shows up in Dagster's UI. So here's our partition table, and you can see that we have 149 materialized partitions as well as a bunch of missing partitions as well. If we click into the asset details page for this asset, we can click on individual partitions to understand more about them. So for example, this is the partition that corresponds to April 1st at this particular hour. And we can see metadata that corresponds to this partition. In this case, the actual file on my local file system where this data is stored. And we can see the run that materialized it. This allows us to understand the logs and what actually happened when this partition was being materialized. If we want to materialize or update a set of partitions, we can click this materialize button. And that gives us an option to choose a particular partition that we want to launch a run to materialize. We can also select a range of partitions to execute a backfill, which is going to fill in all of them. By default, this will occur with a single run per partition. So if we select a range with 117 partitions, that'll be 117 runs, one per partition. But we also have the ability to click this checkbox and execute this backfill in a single run. This single run range backfill functionality is something that we added recently to Dagster, and it's really powerful. It's based on the idea that parallel processing engines like Spark and Snowflake are already built to handle big data. Because of that, you don't need your orchestrator to split up your backfill into a bunch of smaller queries. Doing so would just add a bunch of extra overhead. However, you still do want your orchestrator to understand which partitions were filled in so that it knows they don't have to be re-executed. So this feature allows you to keep track of the state of all these partitions, but delegate the parallelism to a different system. Compared to the multiple run backfill strategy, in some cases, this can make backfills execute literally 10 times faster. And it also means that you don't have to track thousands of runs. So far, we've looked at a single partitioned asset, but partitioned assets can depend on other partitioned assets, which creates a partitioned data pipeline. In the case that's pictured here, each hourly partition of this downstream asset depends on the corresponding partition in the upstream asset. Here's code that implements this pattern. We have the hourly asset that we looked at before, along with another hourly asset that depends on it. If we go back to the UI, we can see both of these assets together. And we have the option to select both of them at the same time and then materialize partitions of them. So when we do that, Dagster is first going to materialize the partition of the first asset, then materialize the corresponding downstream partition of the second asset. And just as before, we can launch backfills that materialize a range of partitions, which will still respect the order of these assets. By default, each time partition depends on the same time window in upstream assets, but we can override this when we want to. So for example, here's an asset that depends on a rolling window of upstream data. Each daily partition depends on the prior daily partition in the upstream asset. Here's how we implement this using Dagster's APIs. We provide a custom quote unquote partition mapping object on the dependency between these two assets. The partition mapping specifies this rolling window by including an offset. If we launch a backfill over both of these assets, then Dagster won't fill a partition of the downstream asset until the prior day's partition has been filled in the upstream asset. Dagster can also handle dependencies between assets with different time partitionings. So for example, if you have a daily partitioned asset that depends on an hourly partitioned asset, then each daily partition will depend on the 24 upstream hourly partitions for the same day. The code for this is very simple because Dagster automatically infers this partition mapping. Here's code that includes the hourly assets that we looked at before, along with a daily partitioned asset that depends on both of them. That's this logins cleaned asset at the bottom. We can see these together in the UI, which is loading. These are our two hourly partitioned assets, and then logins cleaned is our daily partitioned asset. And we can see that it has many fewer partitions than the hourly partitioned asset. If we want to launch a backfill over all of these assets, we can do so. We select a time range, and this is going to respect this complex partition dependency. So what's going to happen is first it's going to, let's say, update the first 24 or the 24 partitions in our hourly assets that correspond to a single day. And it's not going to launch the corresponding daily partition in the downstream asset until those 24 upstream partitions are all materialized. So we just looked at assets that were partitioned by time, but that's not the only way to partition an asset. So imagine an asset is partitioned by country. For each country, it has data on all the weather stations, let's say, for that country. Data for different countries might arrive at different times, so partitioning it in this way allows us to update the data for a particular country without touching the data for other countries. Also, if there's a failure for one country, we can track that failure independently and re-execute the run just for that country without impacting the other countries. We define this asset by constructing a static partitions definition with the list of countries and assigning that to our asset. This country partitioned asset functions just like the time partitioned assets that we saw earlier. So in the asset graph in Dagster's UI, we can see how many partitions are materialized and how many are missing. We can dive in and understand details about individual partitions. So in this case, corresponding to Brazil. And then we can, again, launch materializations that either target single partitions, so single countries in this case, or that target a set of partitions. So far we've looked at time partitioned assets, and we've looked at statically partitioned assets. What if we want an asset to be both? For example, maybe we have an asset that contains weather events from the weather stations that we tracked in our previous asset. Each day, we add weather events for each country. So we want a separate partition for every date for every country. So you can see in this diagram, the rows correspond to dates and the columns correspond to countries. Dagster supports this with the multi-partitions definition class. In this code snippet, we construct one that contains both a time-based partitioning and a country-based partitioning. We can look at this multi-partitioned asset in the UI. And we'll see that when we're trying to investigate partitions, we actually get the option to select on both of these axes. So this is the partition that corresponds to the country USA on this particular date, April 1st. And again, we can see all the same metadata and information that we had in other assets. If we want to launch a materialization or a backfill, we get to select on both of these assets. So we can select to materialize the partition that corresponds to USA on this particular date. Or we can select, let's say, a range of countries and a range of dates and backfill everything at once. The last thing I want to talk to you about is dynamic partitions. In everything that we've looked at so far, the set of partitions is fully determined by the code that defines the asset. But in some situations, we need to be able to add and remove partitions dynamically. For example, consider a data pipeline that creates a derived file for every file that lands in a particular directory. We don't know all the files that are going to land in that directory ahead of time when we're defining our code. Or consider a machine learning pipeline that we want to run with ad hoc hyperparameters to create a set of machine learning models that we can compare. We might not know all the parameter combinations ahead of time that we want to be able to create models for. In Dagster, we can handle these situations with dynamically partitioned assets. So here's a dynamically partitioned asset with a partition for every release of the Dagster project itself. Dagster publishes a release roughly once per week, but some weeks have no releases, other weeks have multiple releases, so it doesn't really make sense to use a time window set of partitions to model this asset. Here's a whole graph of assets that are all partitioned by release. Because they share the same partitioning, if we add a partition to one of them, it will be added to all of them. It's common to combine dynamically partitioned assets with Dagster sensors. Here's a sensor that monitors GitHub for new Dagster releases. When it comes across a new release, it adds a new partition for that release, and then it requests a run to materialize that partition in the whole pipeline of assets that are partitioned by release. We can also add dynamic partitions through the Dagster UI. So these are our dynamically partitioned assets. We're just looking at the screenshot. If we select one of them and try to materialize it, we have the option to select existing partitions. We can also add a new partition, for example, corresponding to a new Dagster release. And that'll include it in the list of partitions for all of these assets. And we can launch a run or a backfill over it. So that's all I have for you today. That was a whirlwind tour of Dagster's partitioning functionality. Using partitions in your data pipelines has some big advantages. It helps you monitor and materialize the subsets of your data that you care about in a particular context. And this gives the peace of mind that you're operating on the data that you need to be and avoids wasting computation and money on data that you don't need to touch. To learn more, visit Dagster.io and take a look at our docs. I'll also be sticking around and answering questions. Thanks a ton.
All right, cool. Thank you, Sandy, for talking through that. Appreciate it. All right, next up, we're going to have Nick talk about the Pythonic config and resources system and the changes that have come into play with that.
Great. Thanks, everyone. Thanks, Sandy, for that talk. The partition system in Dagster is actually pretty incredible. And it's really amazing to see such a whirlwind tour of it. I actually don't think the world knows what we've built enough. But, you know, the partitioning system is something where, like, once you've used it, you can't imagine going back without it. It's really amazing. But I'm not here to talk about partitions. I'm here to talk about the new front end for our configs and resources system that we're shipping with 1.3. Let me share my screen here, and then we'll get going. So yeah, here to talk about our new config system. In the shorthand, I'm calling it the Pydantic config and resources system here. I'm going to go over the goals and motivations for it, what is shipping and examples of it, and also incremental adoption here. So the goals of this work stream are to make our resources and config system modern Python, and make it easier to use and learn, and improved API ergonomics, and also to increase the observability and ease of setup when you're configuring your resources. So let me just walk through a bunch of the issues that are currently in the system. You know, just for some historical context here, this system was built back when Dagster was Python 2 compatible. And for that reason, and we wanted schematized configs for error checking and whatnot. And so we couldn't rely on the Python type system. So we actually built a completely out of band type system for our config schemas. That is another thing you have to learn, which is unfortunate. And so now in modern day, when Python 3 is the norm and Python 3 typing is kind of used more commonly, it feels awkward to have another thing. As a result of this, too many of our APIs are magical strings or untyped. So just as an example, right, you have to, access context.resources.foo if you want to access a food resource, and that's untyped. We have this configured convention around our resources that effectively is object construction, but generally causes confusion. Also required resource keys for those who are familiar. And in general, we have to use the context object too much for common use cases. Other issues here have been kind of warts or holes in our system, is you can't use resources in schedules and sensors. And we rolled out definitions earlier to replace repository, and it was really convenient to automatically bind resources to assets, but we didn't do that for jobs and really felt like a hole in the APIs. So what are we shipping in order to resolve these issues? Well, first and foremost, we now have a Pydantic front end for resources and configuration. Pydantic is a Python library that's kind of ascended in popularity recently, that provides a bunch of validation using kind of an elegant Pythonic API. You can build these classes which have validation routines and whatnot. You can directly access resources via parameters passed to assets and ops rather than through the context object, and that's a strongly typed parameter. Sensors and schedules now support resources, which is great. And we automatically bind the resources passed in to definitions to jobs, which reduces a ton of boilerplate and the threading around of resources object to all the different jobs in your system, ops-based jobs. And we actually have some support for resources in the UI now, which I'll show you a screenshot of. So this is what the code looked like before to configure an asset. You'll see here that you needed to pass in a dictionary that gave a structure. Effectively, this like typed a Python dictionary. And you had to use this kind of manual syntax to say the config consists of a string, which is a type string, and an int, which is of type int. And then you do access it through the context through which you would get an untyped dictionary. This was an issue. Oh, look, I will fix those slides in post. Ignore the third line. But in effect, it's supposed to say equals true. But you can see all the problems here. Now with this new system, what instead you do is you inherit from a class that you import from Dagster called config. And you can just write a plain old Python class. And then you can just make it a parameter on your asset. The config keyword is special for this purpose. If you have a parameter name called config, it is treated as config. And then you can just code against that directly. And you get type aheads in your editor and whatnot. And this is just a ton less boilerplate. And it kind of also makes other use cases way more elegant. For example, before, if you were invoking an asset in a test context, say, you'd have to know to import this thing called build op context and then set the config dictionary to it and so on and so forth. Now, afterwards, you can just invoke after as just a plain old Python function. So you just invoke the asset, you pass it the config option it requires, along with any other thing it requires, and you're off to the races. So this sparks much more joy than the previous way we had to do things. So let's move on to resources. So we build on that Pydantic frontend for config and also use that for the resources system. In addition, we're also going to make them usable on sensors and schedules, and we're going to automatically bind them to jobs when you pass resources into definitions. So let's go through what this looks like. So, and now that we have the new system, actually looking at this makes me cringe. But this is what you would have to do before in order to kind of use the resource system, right? And there's a ton going on here. You would have the class that you're actually going to access in your code, and that's the top one, just a plain old Python class. Then you had to write a decorated function which effectively is a factory method, which returns an instance of that thing and specifies a config schema, right? So you are responsible for shuffling in the config to this object that you're actually going to use at runtime. Then, in order to use it in your asset, you had to declare that, hey, I need this resource. And then you had to know to be able to access that on your context. And then finally, in order to actually use this thing, you would need to call .configured rather than vanilla object construction when you pass definitions. So that's a whole lot of hootenanny is my word of the hour now. And it's just a lot of work to do all this. And it's just like, why do I have to do that? Well, this is what there we go. This is what the new system looks like. It looks just like vanilla Python, which is great. You declare a resource, you inherit from this class called configurable resource, and you can set a value on that, pass it to the resources argument of definitions, and then just have a parameter on your asset. And that parameter name has to be the name of the resource key. And then it all lines up and just kind of works, right? And this configurable resource object is actually kind of a special object that will actually be viewable in the UI, which you'll see in a second, which is really cool. So just to summarize, right? In this, there's no more config schema. There's no more context. There's no more required resource keys, and there's no more configured. So we just swept away a bunch of kind of the weird Dagsterisms and boilerplate that we've rightfully gotten a lot of feedback on in the past. And we think this is just a much better and far more elegant API for this subsystem. Other changes in support here. We also have direct support for environment variables here. So this is fairly clever. You can actually, in the definitions side, set the string to this special thing called mvar, which passes type checking. But then our system actually replaces the value of that environment variable before it gets passed at runtime to the asset. So this is nice because for tests, say, you could just new up a resource and pass it the value that was going to be in the environment variable if you just kind of want to test something out. But for production scenarios, you can say, actually, I want to source this string from an environment variable. Now, and then that evaluation is deferred until runtime. And also we have specific UI support, as you'll see, which say now with this structure, you can actually go into the UI, and in cloud, you could actually update the value of that environment variable directly from the UI. Now, for those who are deep in the system, you've noticed that I use the term source, which there's this thing called string source in Dagster, which has always been a little awkward and weird, to be honest. And you'll notice like that no longer exists. So that is completely hidden from you, at least in the Python API. And you no longer have to think about it. Effectively, for those of you who are kind of deep in this, every single string that you declare on a resource and config, it's kind of automatically a string source. So you can source anything from an environment variable, and that's fine. It's all hidden away from you. So we think this is a big advance in usability. As I mentioned, resources appear in the UI now. As of the release, which is happening a week from next week. It's happening next week. So in this case, we have passed the airbyte resource to definitions, and now it's actually viewable right in the UI. So you can inspect its configuration and kind of understand what's going on. As I mentioned before, if it's an environment variable and you're on cloud, you can actually edit the value of it just right there. And so this is kind of the first step in having resources become more of a first class component in our UIs, which I think is really exciting. And it just provides a ton of documentation for people who are figuring out what's going on in your data pipelines, your data platform, because you can see what the behavior of all these resources are. And we think there's a lot of potential in exploiting the fact that resources are in the UI. And this is just the beginning of that. So we think this is a really exciting step forward. So schedules and sensors. Previously, prior to 1.3, schedules and sensors had nothing to do with resources. you couldn't pass them or use the capability. And the change to actually pass resources to top level definitions actually made this feature much easier to implement. So now, just like an asset or an op, you can just declare a parameter name, and the system will automatically shuffle that resource down to a sensor or schedule. This makes sensors and schedules far more testable and powerful. You can reuse existing code and understand what they're talking to. And we think this is super exciting. And it also makes it just way easier to test, right? So you see in this test, we're like testing the sensor, and just like an asset or an op, you can invoke it and pass an arbitrary resource to it. And so it's way easier to test. And we think this is an exciting step forward. Lastly, definitions level binding of jobs. We released that new API definitions, and we allowed you to pass resources top level, and it automatically bound all your assets to the resources that were passed in. That was not true for jobs, which is kind of, it felt like a hole in the API. So we have fixed it. So you notice in this code example that we no longer have to pass resource definitions to the job decorator. Instead, we can just pass it to definitions, and the system will figure out that, okay, I need to bind the resources to the job. Now, you can still override that in the resources def argument if you want, but we think this is way more ergonomic and result in far less manual passing around of resources. So we're going to end up in a pattern where, like, it's all your resources. You can new them up right next to your definitions object. It's kind of a centralized place to manage all the configuration in your system. And then the system takes full responsibility of threading that down to all the different artifacts that consume those resources. So this just ends up with a lot less manual passing. So let's talk about upgrading or incremental adoption here. So first of all, migration is not necessary. All of this stuff is backwards compatible and everything still works. However, we have super high conviction that this is the right API going forward. So alongside this release, which unexperimentalizes these capabilities, we're also going to move over all of our tutorials, all of our examples, all of our docs to lead with this API. And then we're also adding Pythonic resource and config front ends to all of our integrations. So we're doing a bunch of work to move all our content over. We're not going to break any of your old code, but Google searches and our doc site will all be in terms of this. So we think everyone should, for any active code base, move over to this new API going forward. So we have patterns for upgrading and incremental migrations. We've done it ourselves. And like with any migration, it's critical to break things up into a series of low-risk changes in order to make it so you can make incremental progress. And there's no hard cutover that's super stressful or requires a bunch of coordination. And we have a bunch of patterns and actually built-in utilities to help out with this. I'm not going to go through the entire thing right now, but we will be posting a migration guide alongside of it. But just to give you a flavor of what this looks like, imagine you had this existing code where you had written everything in terms of the old resource system with an @resource decorated function and returns an instance of an object and has the config schema and whatnot. If you wanted to be able to use the new style resource without breaking things that consume the old style resources, we have a pattern for that. So you can, move the object to be a configurable resource and use it just like a new style resource. But here, you can have a single source of truth, and we kind of have these helper functions which make it easy for you to still implement your old API in terms of the new source of truth. So we're doing this throughout our integration conversions and just an easy way so that you can now then think about moving over your various ops and assets one by one, or just make it so net new ones are on the new API. So we also have patterns for, supporting one-by-one integrations for your ops and assets. So imagine you'd done the thing on the previous slide where now you have both a Pythonic front end and an old school front end for your resources. Now here you can actually migrate your assets one at a time, right? And both migrated and unmigrated things can coexist in the same definitions instance. And we do this by we pass things to the parameters, but we still also leave them in the context object. And so that means these two pieces of code can coexist. So you could see here that you could go one by one and move this stuff one diff at a time, one PR at a time in a very low risk manner. And we think this is really important in order to successfully do upgrades. So the plan forward, 1.3 is releasing on Thursday, April 19th. And with 1.3, Pythonic resources config is no longer marked experimental. So configurable resource, config, and associated classes will be front and center and ready to use. And like I mentioned here, I use that word again, tutorials, docs, examples, integrations will all be in terms of this. And we're going to continue to invest in the subsystem going forward. We think, having Dagster have first-class knowledge of all the infrastructure that your data pipelines, your data platform depends on is super valuable and really, aligns with our mission of being that single pane of glass for your entire platform. And with that, I am done, and we'll pass it back to Tim.
Thank you so much, Nick. It sounds like everyone's very excited about all these changes. All right, with that being said, let's move on to questions. The floor is open for any questions from the community about any changes, any features, or anything about Dagster. Yeah. So feel free to post in the YouTube chat if you have any questions. Oh. So is anyone from the team or the community going to be at KubeCon EU next week? Dre would gladly meet anyone there. If you are in the community and going to be there, feel free to email him, DM him on the Dagster Slack. Oh, cool. To fill the time while we are collecting more questions, we are going to make some last final announcements before going on. First of all, do want to say that we have released multiple blog posts on the Dagster blog site in the past few months. We're highlighting 2 here, but we have many more that we've released since then. So if you haven't caught up yet, definitely check out the Dagster blog. Next up, the Dagster team has also put out a lot of new guides and documentation on the official Dagster documentation site, such as a new tutorial and more guides on topics such as automating pipelines, structuring your Dagster project, or building machine learning pipelines. And we've received some questions from the community about, well, okay, how do we navigate documentation? How do we know where in the documentation site to go to? So from a high-level perspective, you can view things as the tutorial as the step-by-step instructions to building out a data pipeline using Dagster. The guides are more walkthroughs, horizontal, and guidance on how to accomplish specific tasks, such as versioning, machine learning, or testing. And the concepts are detailed overviews of Dagster's components and features, such as the ones that Nick and Sandy had talked about today. All right, looks like we have another question. Will you be able to pass resources to resources with the new Pythonic config? Nick, would you like to take that?
Yes, you can. So we have first-class support for that, and it's called resource dependency, and you can just annotate your declaration of the attribute with that. So yes, and it's much nicer. No required resource keys. In the same way, it's much more elegant.
Thank you. All right, let's also just hand it over to Odette really quickly to talk about the Dagstars pilot program.
Great. Thanks, Tim. Hi, everyone. My name is Odette. I'm a developer advocate here at Elemental. And one thing we've been noticing is our community is really great. Everyone helps each other. Everyone is really responsive to different comments, putting out content, even some collaborative blog posts. And we wanted to set up a program that actually recognized that behavior and also encouraged it and highlighted it. So what we'll be doing is piloting a Dagstars program. And what this will mean is you'll be able to access experimental features. We'll be looking to you for feedback on those features, spotlighting some of the work you're doing with Dagster, going to you for some of your Dagster expertise, and also just encouraging you and giving you whatever resources are needed to support the broader community. So look out for Slack. We'll be announcing more details and how to sort of apply for this. But we're really looking forward, and thank you for all your contributions to date. And we look forward to building the community even further in the future.
Thank you, Odette. That's super exciting. All right. So during that, we got another question, which is, will existing resources be refactored to use configurable resource as well? And Ben from the Dagster team replied in the chat there that yes, they'll be moved over to the new system, and the old function style resources will still be available for backcompat. Thank you for asking. All right. Well, last call for questions. Feel free to drop in the YouTube chat. Otherwise, if you decided that you've had a question either after this call or that you're watching the recording later on, we'd love to see you ask those questions in the Dagster Slack, and we'll get back to them as soon as we can. So if you haven't joined the Dagster Slack yet, drop by. It's on dagster.io/Slack. There are thousands of us here talking about Dagster, answering questions, and all relates back to what Odette was talking about, the Dagster's pilot program. All right. Other than that, thank you so much. Have a great day.